Hello Year 11 and welcome to our 7th video here for our 5th topic. We're looking at standard deviation today. Now, standard deviation is a measure of spread. Like range and like interquartile range, it describes in its way how much variation, how much difference there is within the data set. How it does that, you could think of it sort of as being a bit like the average difference between each score and the mean, right? How far different they are from the average. That's only a sort of rough idea of what it relates to, but you know, if we get the idea that the standard deviation will be measured in the same units as our data, and that it tells us how much variation there is within that data set, that should give us a reasonable idea of how to apply this measure. How to calculate it? Well, doing it manually is quite complicated. There are lots of calculations if you do this manually. Fortunately, the very much bright side of this is that we do it on our calculator and it's almost identical, one button press different, almost identical to calculating the mean. Okay, so we'll do that in a moment. I do need to explain some other little things here. When I have a really big data set, and what we might call a normally distributed data set, that'll be in the next video. If, for example, I was measuring the height of everybody in year 11, that's not necessarily a gigantic data set, but nonetheless, I'm measuring the height of people in year 11. There would be a lot of people close that would have a fairly similar height, and that might be something like, I don't know, 160 centimetres. And I might find that between, say, 150 and 170 centimetres, I'd have most people included in that range, something like that. Now, if I just took some of the students from year 11 and measured their heights and said, well, this is probably a pretty good sample. I could select those sample students at random, right? I could use a good reliable sampling method. That's fine. However, if I do that, if I just have a sample, there is a chance that I will have missed the very shortest people in year 11 as well as the very tallest, because there's not very many of those really short and really tall people. So there's not a particularly high likelihood that they're going to end up in my sample. If that's the case, then trying to determine how spread out the data is, right, I'm going to tend to underestimate it a little bit if I don't have the really big and the really small scores. So when I am calculating the standard deviation of a sample, I use a slightly different formula to calculating the standard deviation of the population, because I've got to take into account, I've got to consider that I might have missed a small number of very small and very large scores. So we have a different calculation. Don't worry about it, it's not difficult to work out, but you do need to understand that there's a difference between the standard deviation calculation for a population compared to the standard deviation calculation for a sample. They're slightly different. For a population, we use this symbol here, which is the Greek letter sigma, lowercase sigma. And for sample, we use an S. It's nice and easy. Population and sample. Strictly speaking, you can read the notes here, that if we have a sample, we're talking about statistics. If we have a population, we're talking about parameters. There is a sort of a difference in the mean of a population and a sample, but the really big ones and the really small ones cancel each other out in the mean. So in fact, the calculation for us is the same. Anyway, enough rabbiting on about that. Let's calculate the standard deviation, the population standard deviation for this data set. Thank you, calculator. Here we are. Oh, left over from the last one. Real clear. Second function 9, 3 equals AC. Now mode 2 and 1 to put it in stat mode. And again, you can see I don't need a frequency column. So I'm just ready to go. 4, 5, 7, 8, 8, 10 and 14. Right, there's our 7 scores. Now, if I have a look at those, I would think, well, the mean's probably somewhere around 8 or 9. And how far are the scores generally from that? Well, I think if I had something like 8.5 and I went down 3 and up 3, I'd get most of the scores. So my standard deviation should be somewhere around the 2 or 3 mark, I expect. Righto? Because that's generally how far these scores are away from the mean. Not all of the scores, just most of them. So all clear here. Second function 1. And we go back, remember, to find the mean, we would go to option 4. And it's right next to that. This is the mean, this is the population standard deviation, and this is the sample standard deviation. It says population here, so we need option 3 equals. And there we go. My standard deviation, whoops, equals 3 point, I think it was 1 if I rounded it. Yeah, 3.1 will do. Just a little aside, if the question doesn't specify one way or the other, use the population. Righto? Okay, that'll do. That's it for standard deviation. Not, well, sort of complicated in its way. It is a little bit complicated understanding what it's about, but when it comes to actually calculating it and getting the answer, it is as straightforward as finding the mean on your calculator using step mode. Rightio, hope you enjoyed. See you in class.